So excuse me, and if somebody wants to know more, you can ask me. I'll be until the end of the conference. Be here. And another thing, please ask questions after my talk in Russian. I understand Russian, and I can ask you. So, what is the main thing that explains why we chose this model? It means that in cuprates we observe so-called pseudo-gaps, and we observe which are shown here. Here they are shown. These are the experimental results. There are pseudo-gaps which are very ugly pseudo-gaps that spoil superconductivity exactly in their domain of existence in the lobes, whereas in the node regions where superconductivity is weak, there is no slope. So there are also other phenomena, namely the checkerboard or unidirectional superstructures, which can be called charge density waves. These are peculiar charge density waves. So what do we do in our work? We want to identify those phenomena, pseudo gaps, with charge density wave gaps, linking them to the observed superstructures. Then the model is as follows. We have superconductivity, D-wave superconductivity. Of course, here I would like to tell you that there is this unanimous agreement about D-wave, dx square minus y square, symmetry of the audio parameter is not unanimous. There are also people that think that there is at least an admixture of S-wave constant. But anyway, here it's only a theoretical model. Let us look at the situation when we have a D-wave, superconductivity, and charge density wave. And now I show you, here are also the fact that the situation is disordered. I will talk only about ordered situation. This the smearing due to this disorder will be left for some works in the future. Okay, so what we have? This is S-wave pairing and D-wave pairing, and this is the situation which is observed in cuprates. We have these sectors, these four sectors of charge density wave gapping, and these are the lobes. We consider the more general situation than such a phase diagram on the plane defined by these, determined by these audio parameters. So we have here superconductivity coexists with charge density. Here it's only superconductivity. Here we have a very peculiar state when charge density wave and superconductivity exist in the case of full gapping of all half filled. So we have complete full gapping, dielectric gapping, and still we have superconductivity for in some range of parameters of the system, in some range of this sigma 0. And we have also another very peculiar state when there is when we start from the high temperature, we have superconductivity, then charge density wave appears, and that it disappears, depressed by superconductivity. Why we have such a reentrant state here? Because the symmetry of the audio parameters the symmetries are different, and that is why their temperature dependencies are different. And that is why one depresses another, but not in a complete way. And we have such peculiar state. And I will show you a little bit later. And here is the situation when we have only two sectors. It means unidirectional charge density waves. So I was talking about basically I was talking about four sectors, but four sectors correspond to the system when it's checkerboard superstructure. But when it is the superstructure is only one-dimensional, we have two sectors. And in this case, we have a modified diagram and very interesting situations for other different angles. This beta, which means the angle of rotation against the axis. So this is, of course, it has nothing to do with the situation in cuprates, but who knows, maybe there are some other materials where this situation does take place. Okay. So what should we observe? For some parameters of the system, I wouldn't name them. You see it here. We have such a situation that when it starts this sigma and it dies out. So here it is simply the form is changed, and here it's die out for some parameters. At the same time, delta is, of course, it is changed, but not drastically. So the overall dependence is of the kind we usually have for superconductors. Okay, and so what should one observe when he makes experiments in ARPS? He or she should observe the situation when both gaps interplay, and this ARPS doesn't know whether it's a charge density wave or superconducting gap. Charge density wave gap or superconducting gap. And he will see very peculiar this picture. This is called gap rows when it's not trivial interplay with some non-monotonic dependence on temperature and angle. Mentioned this circumstance, and they proposed their own explanation of this fact. So here what we have the such parameter ranges where it is larger than BCS value and where in the other region where it is smaller. For them, and I will not waste time on reading it myself. Thank you very much for your attention.